let's go ahead and start converting equations. This shouldn't be too hard. So if you see x and y in there and we're trying to convert to polar coordinates, that means our final answer should only have r and theta in the answer. And then other numbers, of course. So just a reminder, x is equal to r cosine of theta and y is r sine of theta. So the reason this isn't too hard is because we just need to do a little substitution for our x and our y and we're good to go. So we've got 3 times r cosine of theta times r sine of theta, and that's equal to 2. And I'll just clean that up. So 3r squared cosine theta sine theta equals 2. And I just cleaned it up by multiplying the r's together. Nothing too crazy. So I love converting to polar coordinates in these equations. Same idea here. So x is our r cosine of theta, y is our r sine of theta. So we're just going to go ahead and do substitution. So I'm going to put r cosine theta in for x and r sine of theta in for y. So we've got 2 times r cosine of theta, and that's equal to r sine of theta quantity squared. So this is 2r cosine of theta equals r squared sine squared of theta. Now if you wanted to clean this up a little bit, I actually would accept this answer. You could actually, since both sides have an r, you could divide them both by r, and you have 2 cosine theta equals r sine squared of theta, but I don't really care. Either answer is fine. So, okay, let's go the opposite direction. Nothing too crazy. So, we're actually still going to use x is equal to r cosine theta and y equals r sine theta for the most part, even when we convert to rectangular coordinates. We're just going to, and then sometimes I should actually specify, sometimes we do use r squared plus y squared equals, x squared plus y squared equals r squared. We'll use that sometimes as well. So this is kind of a special case. I've never actually used the tangent equation. Just a fun fact, just kind of messy. So what I do in this case is I actually look to see so if I see cosine, for instance, that looks most familiar, or it looks closest to this equation right here. However, there's not an r. However, I can go ahead and convert or change this equation by multiplying both sides by r. It doesn't actually change the equation, it just changes how it looks. That way, I match up perfectly with this equation. And so it's an easy substitution. So I know this is going to equal x. Now look how amazing that is, because now we have an r squared, and we know r squared is x squared plus y squared. So I can go ahead and just say this is 2 times x squared plus y squared equals x. Whoa, my thing just went crazy. There we go. So that is your final answer. You can distribute the 2 if you want, so you could write it 2x squared plus 2y squared equals x. Either one works for me. Okay, so same idea with this last one we're going to use. So we've got, let me close, that's probably what happened. So we've got x equals r cosine theta, y equals r sine theta, and then x squared plus y squared equals r squared. Now, I should know, I only really use these two if there is a sine or cosine somewhere in the equation already, which there is not in this equation. So I'm going to be creative, and I'm going to find a way to be able to get an r squared. You could actually just take the square root, but remember, when you take a square root, you have a positive and negative answer. So to avoid that, I'm going to go ahead and just square both sides of this equation over here. So I know r squared is going to equal 49. Therefore, x squared plus y squared is going to equal 49 as well. And there you go. That's it.